Hello class, today we're looking at solving some a little bit more complicated inequalities. So our first question just deals with one-step inequalities where we want to verify our solution. So these are mainly just to remind you of your basic steps. So in question A, we notice that x is being subtracted by 7. The opposite of subtracting 7 is adding 7, and just like an equation, what we do to one side, we do to the other. So our minus 7 and our plus 7 cancel out. We do still have our x on the right side. We have our inequality symbol still, and our 2 plus 7 gives us 9. This is going to be our solution to our inequality, and we always read that from the x side. So we're going to say x is less than, the small side, 9. To verify that, we want to choose a number that is less than 9. So I'm going to choose if x is, let's say, 8. 8 is a number less than 9. We're going to substitute it into this inequality. So we're going to say 2 should be bigger than that 8, subtract 7. 2 is, in fact, bigger than 1, which is the difference, 8 subtract 7. So that point was a working point in our original inequality. Question B, we have 18 is less than negative 9x. Now remember that this coefficient of negative 9 means negative 9 multiplied by x. So what's the opposite of multiplying by negative 9? It's going to be to divide by negative 9. Now we talked in class about how when we do this, when we divide or multiply by a negative number, we have to flip our inequality sign. So when we've completed this division, our inequality sign is going to be facing the opposite direction because we've divided or multiplied by a negative number. With that being said, our negative 9 divided by negative 9 cancels out, leaving us with just our x, and our 18 divided by negative 9 gives us negative 2. Again, read this from the x side, so we're going to say x is less than negative 2. So choose a number that is less than negative 2. So I'm going to choose x as negative 3. And then let's put that into the original inequality. So our 18 should be less than negative 9 times that negative 3. And 18 is, in fact, less than 27. So that did work in our inequality. Question C, what's the opposite of subtracting 15? It's adding to both sides. And we'll say that x is greater than 18. So when we put in a number that's greater than 18 into the inequality, like x is 20, that's definitely greater than 18. And we should have 20 take away 15 is greater than 3, and 5 is in fact greater than 3, so we know that that point worked. In question D, we have negative 32 is greater than or equal to 8x. The opposite of multiplying x by 8 is dividing by 8, which we'll do to both sides. We get x is less than or equal to our negative 4. Notice we did not have to flip our inequality sign here because the operation we were doing was dividing by a positive number. Our solving operation involved a positive number. So let's verify that's correct. Let's choose an x that is less than negative 4. So I'm going to choose negative 5. That's less than negative 4. Then our original inequality says that negative 32 should be greater than or equal to 8 times that negative 5. Negative 32, therefore, should be greater than or equal to negative 40. And negative 32 is, in fact, greater than or to the right of negative 40 on our number line. So that did work. In question E, x was being divided by negative 2. The opposite of dividing by negative 2 is to multiply by negative 2 on both sides. And, of course, our negative 2 divided by negative 2 cancels out on the left side. We have our inequality sign, and then our 7 times negative 2 is negative 14. Now, we do need to pay attention that we did multiply it by negative 2. Since we were multiplying by negative 2, we do actually need to flip our inequality sign. We were multiplying or dividing by a negative number. So, in fact, we should have x is greater than negative 14. So let's check a number that is greater than negative 14. I'm going to choose 0. So if x was 0, we'd have 0 over negative 2 is greater than or equal to 7. Sorry, less than or equal to 7, obviously. 0 divided by negative 2 is 0, which is, in fact, less than or equal to 7. So that did work. Okay, final one is a little tricky here. We could consider this to be more than a one-step equation. Our issue here is that we have negative x, which of course we know is kind of like negative 1 times x, a coefficient of negative 1. So there's a few ways you can look at this. Like our equations unit, probably the best is to get your x positive. And to do that, we need to cancel out that minus x with a plus x. That gives us 11 is less than or equal to 10 plus x. We can then subtract our 10 from both sides and get 1 is less than or equal to x, which means x is greater than or equal to 1. So let's check an x that is greater than or equal to 1. So I'm going to check if x is 2, which is greater than 1. And I'm going to put that in. I have negative of whatever x is, plus 11, should be less than or equal to 10. Negative 2 plus 11 is 9, which is less than or equal to 10, so that one did work. In question 2, we have the same type of skills, but we're just doing a 2-step or 3-step or 4-step inequality based on our grade 8 steps still here. So question A, we've got 4x plus 5 is less than or equal to 13. We don't have any brackets or negative x's to cancel out here, so we'll undo our addition by subtracting 5 from both sides. That'll give us that 4x is less than or equal to 8. And we'll undo the multiplication by dividing both sides by 4, and we'll get x is less than or equal to 2. So to graph that, we're going to, at minimum, mark the value 2 on our number line. Since we can be equal to that 2, we'll put a solid dot at that location. And our x has to be less than that 2, so our arrow should go to the left of our dot to the numbers that are less than our 2. Now, this is the minimum you would need on your graph or your number line. If you want additional marks like 1, 0, and -1, 3, that's fine, but at minimum you need your endpoint marked and your arrow and the correct dot. So let's go ahead and verify. I'm going to go ahead and verify the point where x is 1. So I'm going to say if x is 1, then what happens in my original inequality? I'm going to have 4 times my x of 1 plus 5. So that should be less than or equal to 13. So let's calculate that. 4 times 1 is 4. 4 plus 5 is 9. 9 is less than or equal to 13, so that point worked. You can choose really any point within this arrow. So I could also choose, x is 0. And I could say if x is 0, then what happens with my inequality? That's going to be 4 times 0 plus my 5 should be less than or equal to 13. 4 times 0 is 0. 0 plus 5 is 5. 5 is less than or equal to 13, so that point worked as well. In question B, we don't have brackets, but we do have negative x's. So probably the best approach to this question is to add your 4x to both sides. That's going to give you your new equality. -7 is greater than or equal to 1 plus 4x. Next, we'll undo our addition of 1 by subtracting 1 from both sides. We'll get -8 is greater than 4x. We'll divide both sides by 4 to get -2 is greater than x, which means x is less than -2. So let's mark our -2 on our number line. We're going to have an open circle there since x is not equal to -2. And our arrow is again going to go left since x is less than that -2. And so this will be our solution region in this arrow here. So let's choose some values within that solution region. So we'd have something like -3, -4, -5, so on and so forth. So let's go ahead and check if x is -3. That should be in our solution region. So let's substitute that in. Our original inequality was -4 times -3, subtract 7 is greater than 1. -4 times -3 is 12, subtract 7 should be greater than 1. And 5 is in fact greater than 1, so that point worked. Let's check another point. So somewhere over here would be x is 10, or -10, excuse me. And so let's substitute that in. -4 times our x of -10 minus 7 should be greater than 1. Positive 40 minus 7 is greater than 1. And so that point worked as well. On the back, first thing we need to do is expand our brackets. So we're going to multiply our 2 into our brackets. That gives us 2x plus 6 should be greater than or equal to -4. Open that up a little bit. Next, we'll undo that addition by subtracting 6 from both sides, and we'll get that 2x is greater than -10. We'll divide both sides by 2. We'll get our x is greater than or equal to -5. So again, mark your -5 somewhere on your number line. Since we can be equal to that -5, we'll fill in our circle. Our x is greater than that -5, so our arrow is going to go to the right, to bigger numbers than -5. So of course we might have something like 0, +5, so on and so forth onwards. So let's check those as our verification points. So let's go ahead and check if x is 0 and if x is 5. Whoops, x is 5. So let's substitute those into our original inequality. Our original inequality was 2 brackets, whatever x is, plus 3 should be greater than or equal to -4. 0 plus 3 is 3, and 2 times 3 is 6. 6 is greater than or equal to -4, so that point worked as well. If we put in our 2 with our x of +5 plus 3, that should be greater than or equal to -4 as well. 5 plus 3 is 8, and 2 times 8 is 16, which is greater than or equal to -4, so that point worked as well. In this one here, we do have negative x's, so we're going to cancel those out by adding 2 x's to both sides. We're going to go ahead and say that 8 plus our 2x is less than 5. Next, we're going to do our addition. The opposite of adding 8 is subtracting 8, and we'll get our 2x is less than -3. And then we'll go ahead and divide both sides by our 2 to undo the multiplication. And we'll get x is less than our -3 halves. You could also say that x is less than our -1.5 if you wanted. So to graph that, you could just mark your -1.5 if you want. Or of course you can mark -1 and -2. Place your -1.5 halfway between those. Since we're strictly less than, we're going to have an open circle for our -1.5. And we're going to go ahead and have our arrow going to the left since x is less than that 1.5. -1.5, excuse me. So let's choose some verification values. I am going to choose -2, and I'm also going to choose -10, which would be somewhere that way. So let's check if x is -2 and if x is -10. So in my original inequality, I had 8 is less than 5 minus 2 times whatever my x is. My x here is -2. So 8 should be less than 5 minus -4. 2 times -2. When I subtract negative, it's really adding a positive. So 5 plus 4 is 9. 8 is less than 9, so that is true. Let's put in our -10 next. So we're going to say 8 is less than 5, subtract 2 times that -10. That means 8 should be less than 5, subtract -20. 2 times -10. Subtracting a negative is adding a positive, and 8 is less than 25. So that point worked as well. Final one here, we're going to go ahead and expand our brackets. So we'll expand our -2 into the brackets, and we'll get -10 is greater than or equal to -6 plus 2x. Again, -2 times -x is plus 6x. We're going to go ahead and undo our -6 by adding 6 to both sides. And we're going to get that -4 is greater than or equal to our 2x. Undo the multiplication by 2 by dividing by 2. Yeah, x is this for a -2. So again, for your number line, mark your -2. We can have a solid dot there since we are allowed to be equal to that -2. And again, always read your inequality from your x side. So x is less than our -2. Our arrow is going to be going to the left. The number is less than -2. Let's check some points in our solution region. So after -2, we might have -3, -4, -5, so on and so forth. So let's go ahead and check if x is -3 and if x is -4. So again, we want to substitute those into our original inequality. So just copying that down. The only thing I'm going to replace is my x with my value. So let's do this calculation. So -10 should be greater than or equal to -2 times 3 minus -3 is 6. -2 times 6 is -12. And -10 is in fact greater than or equal to -12. If x is -4, Let's substitute that in. So we want to replace that x with negative 4. That's going to give us negative 10 is greater than or equal to negative 2 times 3 minus negative 4 is positive 7. Negative 2 times 7 is negative 14. And indeed, negative 10 is greater than or equal to negative 14. So that point worked as well. So I hope that's helped you with solving these relatively simple kind of grade 8-step equations. Inequalities, obviously. And we'll pick up with those with some harder ones in the next lesson.